looking at how to use the Cranium to solve either a question that is given to you in terms of using the elimination method or the substitution method using the matrices. So this is purely based on matrices. So those of you, we have the two methods in solving matrices when you are given a question as such. With the Graham's rule, it is a very, very short way of solving any matrix question that is given to you in terms of the elimination or the substitution method. So first of all, when you have the Graham's rule, you have to find your determinant. And the normal way in which you find the determinant, you know how to go about it. But with the Graham's rule, like you'll be given a very shortest possible way to solve for your determinant. And when you are done, you have to find your dx and your dy. Your dx and your dy are the values in which you'll be using here to get your final answer. And it's a very, very simple way to go about it. So let's delve into deeper waters by taking an example here. So we have a question like this. So you've been given a question like this, and with this, you can use either the substitution method or the elimination method. But here is the case in which you are supposed to solve the question in a matrix form. So either you're supposed to go with the inverse matrix formula, where you are supposed to find your adjoints and everything. But with this one, with the Cremers, what you have to do is you have to know that these are your matrices. These are your matrices. So you have your x and you have your y. So you will be needing the determinant. You also be needing your x, that means the dx, the dy. So when we are looking for our dx, anything x is taken out of the equation. So we then deal with the y's. When we are looking for dy, our y's are taken out of the equations and we look for our x. So let's see how we can find our determinant first. So the determinant is d. So d should be equal to, you look at the first column and you write everything down. So you have your 3, and your 5. Then you come to the second column. You have your 3, your 5, and your 9. Then the third column, your 5, your 9, and your 17. So after you have done this, then you come back to take the x and y of this main matrix. That is this column again. So you are getting 3, 3, 5, then 3, 5, 9. This is how to go about the determinant. So first of all, you write everything down in accordance with the x and y variabilities. So looking at the x column, you have everything down. Looking at the y column, you have everything down. Then looking at the z column, you have everything down. Then what do you do again? Then you come and, because it's the determinant, you are taking determinant of x and y, you come to the column of x again, you multiply the column of x, then the column of y together. So when you are done, what you are supposed to do is to just take the first diagonal. Take the first diagonal and multiply. Then you move to the second diagonal, then you multiply. Then it goes to the third. So this is how it's supposed to be. The first diagonal. So it goes like this. So you are multiplying everything here. Then you go to the second diagonal. So here, like this. You multiply everything. Then you go to the third, everything. Then you multiply. So here you are having 3 times 15, 3 times 5 times 17. Then because we are moving to the right hand side, it's supposed to be positive. So plus 3 times 9 times 5 plus 5 times 3 times 9. When you are done, then you also come to the negative side. So we are moving this way too. So we are moving to the negative side. So you come and start from the outside. So this one also comes like this. The first column. So it goes like this. So like this. Then you come to the second column like this. Then you come to the third like this. So you sum this as well because it's also moving to the negative. Whatever you do becomes a negative, a minus here. So if it is 5 plus